Hello, welcome back to Catholic GayTube. It's been a while. I've been busy. I had some repairs that I was working on that were taking up bench space, so I wasn't able to do any sort of videos or content. Today, we're doing mail. I know I feel like I only can produce CRT videos and like mail opening videos, but that's the way things are right now. So in this box I have nothing very exciting, really. Oh, it's heavy. Look, I got one of those like $50 variacs from eBay. It's very tiny. It's very tiny. I thought it was gonna be like big because I'm used to like lab equipment where it's like big, but this is like tiny. It is this is the cheapest thing I've ever held in my hands. It feels like it was made for like $11. Maybe that much. I'm this does not feel good. It doesn't sound good either. But it's better than nothing. It's got a 5 amp fuse and a 130 volt limit. I really wish it had some sort of current monitoring. It does not, it just has this little voltage indicator, which we'll see how accurate that is. I really wish it had current metering. I might modify it to have that because those little current meter module things are so cheap. Whenever you're powering something up for the first time and you're not really sure if it's gonna work, you wanna have protection against short circuits. So with a current monitor or current limiting supply, you're able to see how much current the unit is drawing. And you can set a current limit of, say, 1 or 2 amps. In the case of these CRT units, where you don't really want 5 amps of AC power going through your high voltage transformer if you aren't sure if it's going to work correctly. But today, I thought that instead of looking at something that I've been working on, because I haven't been working on anything, I thought we would look at some more heavy stuff. I thought we would look at some new things that I have now. Look at that. There's 2 of them. They're similar. They're not exactly identical, but they're similar. Telequipment oscilloscopes. I got them for very cheap on Craigslist along with some other stuff. When I initially got these home and I was playing with them, one of them turned on just fine. And it didn't work very well. The controls were really fucky and dirty and needs a lot of work. The other one of these, when I turned it on, it sparked at me and like there was like you could see like a big flash inside and everything. I don't remember which is which. I didn't label them. I didn't take any notes about like serial numbers or anything. So the reason that spark happens is because you have a short somewhere, or you have something is wrong and you're giving it the full power. So there's an opportunity for that voltage to build up to that unsafe level. With the variac, you can control the power going to the unit, so you're able to more slowly ramp up the voltage so that the unit doesn't immediately like explode. It just slowly explodes. So now we have our variable power supply, our oscilloscope, our pile of garbage. Don't worry about it. So if we turn on the scope, turn on the variac, we adjust our voltage to 110 volts. On the label, it doesn't say 110, but I'm following the dial because I figure I might as well. So yeah, it works. Hooray! We get our deflection and whatever. I like that. Let's stick a probe on it. Do I get anything? Huh. Okay. Well, let's feed it a little something. So this is just a sine wave from my function generator. Let's see what we got. Huh. We don't get anything. Oh, okay. Okay, so it's very... There we go. Okay. Okay. Great. There's our sine wave. These controls are very dirty, so that even like nudging them a little bit sends... Oh, please stay still. Sends the whole thing out of whack. But it looks very pretty. This is a very nice little, oh, it focuses up very nicely. This is a very nice little green CRT. It's a little dimmer than it appears on the camera in person, which is fine. Oh boy, a lot of connection issues. As you can see, our trace is really wigging out right now. But I don't think that's just the scope's fault. There's some pretty shitty probes. Okay, so this one works like fine. Let's fire up that other one and see if it works or if it behaves better under a slow power up. Oh my goodness. Ugh, the handle moving just scared me. Okay. It's scary because I know this one has an issue. Brightness up a little bit. Oh gosh, I'm filming this one because if it jumps at me, I'm only going to do this shit once. Oh, there's a trace. It's moving around because, oh, sorry folks, just trying to focus. It's moving around because the voltage changes the amplifier. Does that do anything? No. So I think that brilliance control is dead because it's not making it any brighter. So I think it might be fused open, welded open or something. I don't know, I'll figure it out. But it does turn on and it didn't jump at me. So this is the same scope, the same unit. And the meter is about at 100 volts right now. And if I turn it on a little more, whoops, come back here. If I turn it on a little more, it comes on all the way. Sorry, the trace keeps moving around. So if I turn it on a little bit more, it comes on. Oh, there it is. And yeah, I was right. The brilliance control does nothing at all. So there must be a short somewhere in there. But if we turn the voltage down a little bit until the scope turns off, oh, you can see it scurries away. It stays, and then a little more. It scurries away. Let's see if the time base changes that. Oh, we can see it changes it, how it appears. But I think that waveform, oh boy, really playing with fire here, is our mains voltage or some sort of hum on our plates or something. I don't know. Because it doesn't seem to be affected by the horizontal deflection. But anyway, yeah, we could turn this thing all the way up to 110 volts, and we have to keep adjusting the vertical because of the changing deflection voltages. What do I think of the $50 variac? I don't like it. Really quickly, I want to show you the documentation that came with it. There's a contact voltage regulator certification. I don't know what the hell any of this means. There is not spark phenomenon between the contact surfaces of copper wire with running carbon brush. That's good. So that means that there's no sparks. Like in AC motors, there will be sparks in brushed motors. Yeah, there will be sparks and it will wear away the brushes. So I guess that's good. So between the minimal build quality and the minimal documentation, I don't trust this thing to keep me safe, but I know that it probably will. Most likely I'm going to switch the 5 amp fuse that it comes with over to a 2 amp fuse because that's what I mostly use. I'm most accustomed to a variac that has a 2 amp and a 7 amp setting. Without that, I'd rather have the 2 amps. So going forwards, I would like to repair the one that is not functioning correctly. And I would also like to clean and restore a little bit the one that is working. These aren't going to be like factory whatever, but they are going to be working correctly and hopefully calibrated. I have some other things that I acquired recently that I have to calibrate, and that's scary because I want to do a good job. And it's not something I've ever done before. So if you have a history of calibrating laboratory test equipment, tell me all about it. What was your favorite part? What should I be on the lookout for in my pursuit? I think that's all for today. I will probably be uploading more regularly soon, now that I have safety equipment and stuff to work on, I guess, stuff to show you guys. So, yeah, leave a comment, subscribe, like, and share. Follow me on Instagram. Okay, bye.